Today we'll be covering the first half of section 1.5 about how to solve and graph inequalities. The different types of inequality symbols are given below. The first one is read as either less than or fewer than. The next one is read as either greater than, more than, or exceeds than. And those two we've already covered. The ones that are new is this one with the less than symbol with the line underneath. What that means is it's less than or equal to, no more than, or at most. And the far one on the right is the greater than symbol with the line underneath. And that's read as greater than or equal to, no less than, or at least. In order to graph an inequality, you're first going to make sure the variable is written first. Then determine if the circle is open or closed using the inequality symbol. If you have a greater than or a less than symbol, basically without the line beneath it, you're going to use an open circle. So you would plot a point with your open circle. If it's greater than or equal to or less than or equal to, you would use a closed circle or just a traditional point. Now you're going to determine the direction of the arrow using the inequality symbol. So if the inequality symbol is pointed to the right, like in a greater than or equal to, our arrow will go to the right. If the inequality symbol is a less than or equal to, it's going to point to the left. This slide summarizes what you would do for each symbol. So as long as your variable is written on the left-hand side, you can use this grid as a guide, which is on your note sheet. For the first example we have here, it says that x is greater than -5. So what that means is we're going to go to our -5, and since it doesn't have the line below, we're going to draw an open circle. Then, because our variable is written first, we can just draw our arrow in the direction of the inequality symbol. In our next example, we have n is less than or equal to 3. So that means we're going to go to our +3, and we're going to draw a closed circle because we have that line underneath. Then we're going to draw our arrow to the left because of the inequality symbol. For the next one, we have r is less than -3. So we're going to go to -3 on our graph. We're going to draw an open circle because there isn't a line underneath. And we're going to draw our arrow to the left, following the inequality symbol. And the last one, since it says b is greater than or equal to -1, we're going to go to -1 on our graph. Since there's the line underneath, we're going to put a closed circle, and we'll draw our arrow to the right. In the next example, it says 1 is less than or equal to x. Now, we had said before that we always want to have our variable written first. So we're going to rewrite it so x is on the left-hand side and 1 is on the right-hand side. However, we have to flip our inequality symbol so that the bigger side is still open to whatever was open to the bigger side before. So we still want it to open towards x, so we're going to copy that. Now we're just going to graph. So we go to 1 on our graph, we put our closed circle, and draw an arrow to the right. We're going to rewrite our inequality here. So we put k on the left side and -2 on the right. And since the inequality symbol is open towards the -2 originally, we're going to open it towards the -2 for our new graph. So we find -2, use an open circle since we don't have the line beneath it, and we're going to draw our arrow. Now, in order to solve an inequality, the process is nearly identical to solving an equation. So for this first one, you're going to use inverse operations. So if I wanted to isolate the x, I'd have to get rid of that -3. And the opposite of subtracting 3 is adding. So I would add 3 to both sides, and that's going to give me x is less than 8. We just carry that inequality symbol down. Now we do the same thing again, except for we're going to end up using subtraction. So our inequality was x plus 6 is greater than or equal to 10. To move that plus 6 over, we would have to subtract 6 from both sides. So that's going to give us x is greater than or equal to 4. Again, just carrying that inequality symbol down. In our next example, we're going to solve the inequality and then graph the solution. So if we wanted to get n by itself, we'd have to undo that subtracting 4. So we're going to add 4 to both sides. And that will give us 2 is greater than n. However, we always want to make it so our variable is written on the left-hand side. So if I were to rewrite this, n is going to be on the left side, 2 will be on the right side, and I want to keep my inequality symbol open towards the 2. Now I'm going to graph it just like I did before. So I go to positive 2 on my graph, I use an open circle since there's no line underneath, and I draw my arrow to the left. Now, the one key difference between solving an inequality and an equation is when you're multiplying or dividing a negative number. Whenever you multiply or divide each side of an inequality by a negative number, you must reverse the inequality symbol to maintain a true statement, which means you're just going to flip the direction of your inequality symbol. For example, in this case, we're going to end up having to multiply both sides by a negative number. So as we see here, we have x divided by negative 2. If I want to undo that division, I multiply both sides by negative 2. However, because I'm multiplying by a negative, that means I'm going to have to flip my sign. So these negative 2's cancel out on the left, so it becomes x. 4 times negative 2 gives me negative 8. And now instead of opening towards the right, I have to flip the inequality symbol to open towards the left. The same process is true when you're dividing by a negative number. So in this case, we have negative 2x is less than or equal to 6. In order to get rid of that negative 2 in front of the x, I have to divide both sides by negative 2. However, again, because I'm dividing by a negative, you have to flip the inequality symbol. So it's going to become x. 6 divided by negative 2 is negative 3. And I flip my symbol to now open to the left, and I maintain that equal to line underneath. Here's 2 other examples with solving inequalities with multiple steps. So if I wanted to solve my first inequality, I first have to undo that minus 3. So I would add 3 to both sides. That would give me 2x is less than 11. Now the next step is I need to get rid of that positive 2. So I would divide both sides by 2. Now it would give me that x, 11 divided by 2, is 5.5, but my inequality symbol stays the same. When we're dividing by a positive, we don't have to flip the inequality symbol. In our other example we have here, we're going to do the same process of solving. So I first need to undo that adding 7. So I subtract 7 from both sides and get negative 3x is less than or equal to 6. Now I'm going to divide both sides by negative 3 to undo the multiplication. I'll get x. 6 divided by negative 3 is negative 2. And because it's dividing by a negative, that means that you have to flip your inequality symbol. So now it's going to open towards the left, and I carry down the equals to. Now we're going to put all together in one final example. So the first thing we have to do is bring all of our variable terms to one side. So I've decided that I'm going to subtract 10x from both sides. So that'll give me negative 3x plus 9 is greater than or equal to negative 12. Now I'm going to move the 9 to the other side. So I'm going to have to subtract 9 from both sides to give me negative 3x is greater than or equal to negative 21. Now the last step is I have to undo that negative 3 in front of the x. So I'm going to undo that multiplication by dividing both sides by negative 3. But again, remember, because we're dividing by a negative, you have to flip the inequality symbol. So it will become x, negative 21 divided by negative 3 is positive 7. And I flip my inequality symbol to open to the right. Now the last part is I just put it all together. So I put my closed circle at positive 7, and I point my arrow to the left.